Now let's see this first normal form. Whenever you create a table, depending on the type of attributes, the table might not be in first normal form, and one such attribute is called as multi-valued attribute. So if one of the attributes of the table is multi-valued, then there is a chance that the table is not going to be in the first normal form. So according to the definition of first normal form, we want the table to be as flat as possible. Flat means we want to have only atomic attributes. We don't want to have a list of attributes or attributes which are not atomic. So I'll take the two types of attributes which will violate this first normal form, and I'll explain you how to deal with them. So first thing is, assume that there is a table. Let us say first one is employee number, one attribute, and the other attribute is employee name, and the other attribute is phone number. Okay. Now assume that one employee is having employee number 1 and his name is A, and he is having more than one phone numbers. Now such an attribute is called as multi-valued attribute. Now that is a violation of first normal form. First normal form says that all the attributes should be atomic, but then if you see the phone number, now assuming that a person can have more than one phone number, now the phone number will become multi-valued attribute. For example, let us assume that the phone number is one is 1234 and other is 5678, which means this person is having two phone numbers. Now it is not an atomic attribute, it is a list of attributes. I mean, it is not an atomic value, it is a list of values, right? Now how to deal with it is, okay, I'll take one more entry, 2B, let's say something like this. Two numbers are there, right? So for this one, two numbers are there, and for this one, two numbers are there. Now how to deal with this is, there are two ways to get the table into first normal form. One way is, for every phone number, maintain a separate entry in the same table. That is the one way, right? So which means, for every phone number, we are going to maintain the separate entry. So let us say this is employee number, employee name, and then phone number. Now 1A 1234, and again, which means for this phone number 1234 I have maintained one entry, and again for the next phone number 4567, right, I am maintaining one more entry. Got it? Which means for every phone number, if I maintain a separate entry in the same table, this is going to be one approach. But as you can see, this is obviously, it is not a good approach, because if you observe it, there are a lot of redundancies. 1A is repeated, 1A is repeated, right? So it is not good. Now, on the same grounds, you can also do for this 2B, 2B, since he is having 2 also is having two numbers, 254718, right? So now what the other approach is, try to maintain two different tables, one having the original values and the other one is specifically to maintain the multi-valued attribute. So in this case, the multi-valued attribute is phone number. So try to create a new table for this attribute, and in that attribute, whatever is the primary key for the original table, maintain that primary key in the second table as a foreign key referring to this primary key, right? Now what I mean to say is, the other approach is, you try to split it into two tables. So one table will contain the original employee details. So one is employee number and the other is employee name. Now employee number 1, employee name A, employee number 2, employee name B. Fine, this part is clear. Now in the other table, we are going to maintain the attribute which has created the problem. That is nothing but the multi-valued attribute, which is phone number in this case, right? So for that, we are going to have one attribute phone number, and the other attribute is going to be employee number only. Now this employee number should refer to this original primary key as a foreign key. Got it? So whatever is the primary key here, I am going to maintain that primary key as a foreign key referring that original primary key, right? Which means, one, if an employee is existing there, then only one entry will be here, right? Otherwise, if there is no employee here, why do you want to maintain the phone numbers of an employee who is not there in the company, right? So 1, so because 1 is having two numbers, right? Now what are the two numbers? 1, 2, 3, 4 and 4, 5, 6, 7, and 2, 2, what are the two numbers? 1, 2, 5, 6 and 4, 7, 1, 8. Okay. Now what should be the key for this? I'll combine, see, one cannot be a key here because one is not unique. So I'll combine these two, employee number and phone number together will form the key, right? And one will be the foreign key and these two will be the primary key for this table. Got it? Now one will be referring to this and both of them will be unique for the entire table, right? Now what is the advantage of this approach compared to this approach? You can see that A is not repeated many times, even though ones are repeated, right? So you can assume a table which is very big, which is very broad, in the sense if you have many attributes here, right? If I go with this approach, I'll have to repeat all the attributes for every phone number, right? But here if you observe it, I'll be repeating only the employee numbers for every phone number. Therefore obviously the second approach is better, right? So you can go with any approach. What I mean to say is there are various ways of dealing with it. So whenever you have these multi-valued attributes, the table is not in first normal form, because according to the definition of first normal form, all the attributes should contain atomic values, and since it is not atomic, we are going to go with any of these two approaches. Now the other problem is there are some kind of attributes which will be called as composite attributes. Now if we talk about name can contain first name and last name, right? Let us say we have a table in which there is employee number, and for the sake of simplicity I'll assume that there are only two attributes. One is employee name, and now when I say employee number is 1, then if I try to write the employee name in one attribute, then the employee name itself might contain more than one atomic value. For example, first name and last name, right? Ravindra Babu is the first name, Rahula is the last name. Like that, every employee might have first name, middle name and last name. Now again, if you see this, they are not atomic, they are not single values, right? So again, this is going to create a problem in first normal form. We don't want to have anything which is not atomic, right? Then what we do is, again we can deal with the same way how we dealt with that. We have to try to find out a solution here. So instead of dropping out this attribute altogether, we have to deal with it, because this is important information, we have to save it somewhere, right? So how we deal with it is, one is maintain separate attribute for every let us say the composite attribute is a combination of various atomic attributes. Now identify all the atomic attributes that can be present in this, and now separate that compound attribute into various atomic attributes, which means let us assume that employee number is there. Then split this employee name as first name, middle name and last name. Now what happens? Employee number 1 will have first name A, middle name B and last name C. Now if you observe this, everything in this table is atomic. Therefore again this table is in first normal form. Got it? So and there will be one more case. The case will be nested attributes. Nested attributes means attributes can be both multi-valued as well as composite. So for example, if you see, if a person is having two addresses, address itself is a composite attribute, because it is going to have door number, street number and all this, country and all. Address itself is a composite attribute. Now if a person is going to have more than one address, then it is going to be multi-valued as well. Therefore there can be some cases where an attribute will qualify to be both as the multi-valued as well as composite. Such attributes are called as nested attributes. Now we have to deal with it using these two approaches, right? First you split it out like this, and then you can split it out like this. Got it? So let's see the definition given in the textbooks. We'll go for normalization in order to remove redundancy. So generally that is why we go for normalization. It is not just for first normalization. In any normalization, why we apply it is to eliminate the redundancy. Now in first normal form, attribute values in a table should be atomic. Atomic means as simple as possible or as small as possible. You should not be able to divide them further. That is, neither multi-valued attributes nor composite attributes are allowed. Now every table is in first normal form, since the formalized definition of the relation guarantee that the attribute value should be atomic. So in general, when you are coming from the definition of the definition of relation itself says that relation is a cross product of two sets, and each set is going to contain atomic values. Therefore whenever you say that the set is containing atomic values, all the attributes are supposed to contain atomic values. So the formalized definition itself guarantee that every table is in first normal form. So you cannot, there cannot be more questions on this topic, first normal form. The reason is, by default every table will be in first normal form. In case if there is any violation like this, we'll again split it. Okay.